Hello guys, good day to you. Welcome to queue with linked list implementation. Today we have built a program that has implemented a queue link data structure, which is a first in first out data structure with linked list. The reason why we've done that is that with an array, queue with an array has a definitive size, as we all know. And that size may be exhausted once we have filled it. For example, an array size of 1,000, if we insert 1,000 elements in it, it will eventually get exhausted. So then we won't be able to use that array anymore. The second disadvantage is that if we don't use all of the space in that array, that space memory gets wasted actually. So here we have implemented the queue with a linked list. Before I go on to explain the code, I will give a little bit explanation of how an algorithm can be efficient. So the first thing that an algorithm has to have is that it has to be cost efficient in terms of time. A good algorithm takes less time and less space. But sometimes there are trade-offs between time and space, which we call time and space complexity. An algorithm that takes less time will take more space, or an algorithm that takes less space will take more time. The space and time complexity of this program is that it should have a big O notation of 1 when we are inserting or enqueuing or dequeuing from the nodes from this algorithm. If it doesn't do that, then the algorithm is not efficient. That would mean that the big O notation will be n times. What happens with big O notation of n is that when we enqueue at the rear of this linked list, the program has to traverse from the first node to the third node, going to the second and to the third. We can actually do that by creating a temporary variable and setting the address of the front into it. And then by simply saying temp equals temp next, we can go to the next node until we reach the rear node. A simple while loop would do that. And if we want to insert this node here, we can change the null pointer of the pointer value of this node to the address of this node, and then this link will be created here with this arrow, and then this now will mean that the linked list has now been ended, or the queue has now been ended. The problem is that every time there's a traversal, it takes more time. For example, if this linked list has a million nodes, and each traversal takes 1 second, that will mean that the whole program took 1 million seconds to execute, because we were enqueuing at the end of the linked list. So this is not very efficient for a program or an algorithm. This could be the worst case scenario of this program. To solve this, what we do is that we start from the rear end of the linked list. The benefit of this is that it doesn't have to traverse to every node to get here. So for this, we create a node first, a temporary pointer. This temporary pointer's data will be holding this value, 17, and the next would be set to null. This basically creates a new node for us. And since we're adding, for example, this, and then this, and then this, every time the rear will be changed, the address of rear will be changed to the new node. So if this node gets added, this rear should then will be equal to 104. And then when that happens, we set the rear next to our temporary variable here, which is the address of 104. And then this value becomes 104 here. This is how the enqueue works with an efficient algorithm of queue with linked list implementation. Now for dequeue, Since this is a first in first out data structure, as we said in the beginning, it has to dequeue from the beginning. So whatever node comes first, it has to go out first as well. So for that, we create a temporary variable, call it temp. This is a pointer, and we set the address of front in this pointer, temp equals front. And now temp will be storing 100. And then we simply delete this link here. This link will be deleted when we say front equals front next. So front will now be pointing to this address, 101, and this link will be deleted. But now the memory still has the value of front still in it. So for that, we say delete temp. Delete is a built-in function, and when we delete it, this whole node and its link will be deleted and front will be set to 101. So that's all for the explanation of the algorithms. Now the program itself works this way. So we create a structure, we set an integer variable, we set a pointer called next, we set two other pointers called front and null, to front and rear to null, we have a global variable called value, and then we have a class. So what happens is that, okay, this is basically this, but to make sure we just added another thing here so that the program, we are sure that program runs efficiently. I'll explain this function later. It just returns true or false if front and rear are null. So for the enqueue, we have, as I said, create a temporary variable, and then the data is value and next is null. So this creates a node for us. And we have an if condition that checks if front and rear are null. So if they are null, that means that, for example, if we have this node here and we don't have all of this here, and if we have this node, that would mean that the front and rear are 0, they are null. And if we enter here, front and rear becomes 100. So this is basically what this if condition means. So if we have more than one node or more than one node, it will skip to this piece of code. So rear next becomes temp, as we said in enqueue, and rear becomes temp. For dequeue, the same thing, a couple of if conditions to check for nulls, and then it works in the same way as I explained before. And then we have a display function to display our queue items. So let's compile this. It gives us options. So I'm going to choose enqueue. I enter a variable, enqueue, I enter this variable, and I enter this variable. And I display it. My queue variables are this. And since the data structure says that the first variable entered should be dequeued first, when I spell dequeue, 23 is gone, and then we have these two. So the similar way we can delete these two as well, and then we have null values, the queue is empty. So this is how the program works. I hope you enjoyed it. Have a good day. Thank you.